Hello everyone, here we have a brilliant question of the kinematics. A car is moving on a circular path of radius 600 meter. You call this as R. The magnitude of the tangential acceleration and the centripetal acceleration is given as equal. So for solution, we will write that the magnitude of the tangential acceleration and centripetal acceleration are equal. The car completes its first quarter. So let's draw that here. Suppose this is the circle at t is equal to 0. The car is t initial. This angle theta we also consider as 0 radian. And the radius is given as 600 meter. The car has the initial speed of 15 meter per second. And after this much interval of time, we call it, let's say, lambda, because it's a bit lengthy expression, so we call it, let's say, lambda. At t is equal to lambda, the particle completes the quarter circle, means the angle traversed is pi by 2 radian. The car moves from here to this location to complete the quarter circle. Okay. Now, the question is asking us the value of this capital T involved. We have to find its value. So let's start the calculation. The tangential acceleration you can write as alpha r. The centripetal acceleration you can write as omega square r. R and r getting cancelled out. Alpha you can further write as v by dt of omega, and here was the omega square. Bring this omega square into the left hand side, so omega to power minus 2 d omega. Bring that dt to the right hand side, so here is the dt. Now you have to integrate it in proper limits. To put up the limits, let's have a look again at the language of the question. T is equal to 0 is this moment. At this moment, how much is the omega initial? The initial angular speed is required here. At t is equal to 0, we require the omega initial. Omega initial would be v initial divided by the radius of the circle. V initial was mentioned in the question and we have converted it into the SI units. So 54 into, at the place of kilometer, you will write 1000 meter. At the place of R, you will write 3600 seconds. When you further compute it, you simplify it, it comes out to be 15 meter per second. It means the V initial is 15. R was given as 600 meter in the question. So 15 by 600, it returns 1 by 40 radian per second. This is the omega initial. Put it here, 1 by 40. Let's say at some time t, its angular speed is omega. So the upper limit is t and the angular speed is omega. Now we are taking the calculation to the next page. Keep this expression in your mind. We are taking this expression to the next page. So here we have 1 by 40. Here is omega. Here is omega to power minus 2 d omega. Here is dt. The limit is 0 to t. Okay. Now simplifying further, omega to power minus 2 plus 1 upon minus 2 plus 1. The limit is given in the question. Simplifying it here, integral dt will be t. Limits are from 0 to t. Going further, here is omega to power minus 1. Minus 2 plus 1 is minus 1. Divided by minus 1. The limits are 1 by 40 and omega. Here when we put the upper limit, it is t. Then we put the lower limit, 0. Okay. So you can write 1 by omega. The limit is 1 by 40 omega, and minus sign we have taken here. This minus sign can be taken here. Now put up the data. Upper limit, so 1 by omega, minus lower limit 1 by 40. Keep in mind, at the place omega, you will put the lower limit. Here we are left with minus 2. Simplify it further, 1 by omega minus 40. There is a division sign, there is another division sign, the 40 goes to the numerator. Is equal to minus 1 by omega can be written as 40 minus t. I hope you agree with this. We know another thing that omega is d by dt of theta or d theta by dt. You need 1 by omega. So bring that omega here, bring the dt here, d theta here. So doing that calculation, bringing the dt to the LHS, d theta to the LHS and shifting the omega to the RHS. dt by d theta is 1 by omega. Replacing the data here, taking the calculation further. At the place of 1 by omega, you will put dt by theta. And then you are left with 40 minus t. Now the expression is dt upon 40 minus t is equal to d theta. We have to again integrate this expression in proper limits. So that we'll do on the next page. We are having the expression dt upon 40 minus t is equal to d theta. Now we need the proper limits. Initially, t is equal to 0, the theta is 0. If we check at the page number 1, initially at t is equal to 0, the angle theta is 0. And at some time lambda, we call this time as lambda, it's a big expression, so just I am naming it lambda. At some time lambda, the angle traversed is pi by 2 radian, so getting it here. At time lambda, the angle traversed is pi by 2 radian. Fine. Now, we should be knowing the integral format for this. Dx by ax plus b is equal to 1 by a log base e ax plus b plus some constant c. This is a formula of integration. Okay. Compare the things. I am writing it in proper manner. 0 to lambda dt upon minus 1t plus 40 is equal to 0 to pi by 2 d theta. Now you can compare the things. This minus 1 serve as a, this t serve as x, and this serve as b. And then we will get the data accordingly. So integrating it, what we will get? 1 by a means 1 by minus 1. Again, we'll shift that minus to the right hand side for simplicity. Log base e. And then we put the data minus 1t plus 40. Okay. The limit goes from 0 to lambda. Here on integration, you get theta. The limit goes from 0 to pi by 2. Agree with it? Taking the computation further. This minus sign, we will bring it to the right hand side. So here is log e minus t plus 40. The limit is 0 to lambda. That minus sign, we are bringing it to the RHS here and then putting up the limits. Put up the upper limit as pi by 2, the lower limit is 0, and this minus sign has been taken here. Now put up the limits here also. At the place of t, we will put the upper limit. So log base e minus lambda plus 40 minus log base e minus 0 plus 40 is equal to minus pi by 2. Here is something log m minus log n. There is another formula in the mathematics. Log base e m minus log base e n is equal to log base e m by n. Now we'll be utilizing this formula. So it will be written as log base e m by n. So m is 40 minus lambda. And this n is only 40. Here we are having minus pi by 2. Now we'll be taking anti-log both sides. When we take anti-log both sides, here the log will be gone. Divide the 40 here, so 40 by 40 minus lambda by 40 is equal to e to power minus pi by 2. 40 by 40 will become 1. We are taking this calculation again to the next page. Now, this 40 also I am shifting to the LHS is equal to lambda. Now that lambda was given to us on the page number 1, the lambda was this expression, capital T bracket 1 minus e to power minus pi by 2. So putting up this data, this lambda was equal to capital T bracket 1 minus e to power minus pi by 2. And here is 40, 1 minus e to power minus pi by 2. If you compare, this is matching in the equality. Here is equality, this and this bracket is matching. It means how much should be the T? The correct answer for T is with us. Your T is actually 40 seconds. We are working in the SI system. I hope you got the solution. If you have any doubt, you can post that in comment box. We'll discuss it, we'll resolve it. If you enjoyed this video, please like it, share it with your friends and kindly subscribe to this channel. Stay awesome. And there is one more interesting fact since you stayed up to here. This answer which we got as 40 is directly coming. Take this data, it is in meter. Take this speed, it is in meter per second. What I mean to say, your answer T comes out as 600 meter divided by 15 meter per second. The meter and meter is getting cancelled out. When you compute it, the answer is 40 seconds. That was the required number. Can you guess how this number came out?